Alright, here we are. I'm setting the center line height for my radius tool. I'm just gently pushing against a ruler, and if it leans away from me, then I know that I'm above center line, and if it leaned towards me, I would know I was below the center line height. Um, I actually forgot to hit record, and I missed the part of turning the part down to the 0.610 diameter. Uh, That's a bummer. But right now I'm just making a line that's a quarter inch away from the shoulder because that's how wide the groove is at that location. The scribe marks really isn't showing up very well. Um, if I had just used a ruler and a regular scribe, I I could have got a deeper mark. It takes a little bit more time. To locate this groove, you see it's 2.5 inches from the shoulder to the right side of the groove. So I'm just butting my ruler against the shoulder and then lining up the edge of my radius tool at the 2.5 inch mark. Immediately replace the center. I had to move the center out of the way so that way the ruler could lay flat against the part. Now the RPM, this is an interesting situation. The radius tool makes a large amount of contact with the part, so you have more tool pressure. I often tell students that they will have to run their part at a lower RPM than they would when they were turning their part. So just remember, if you get chatter from a cut, one of the first things you should ask yourself is, am I going at a faster RPM than I need to? Now, if you see up there, I'm trying to show you the dials and what I'm doing. I'm going in and I stopped on a whole number. You remember what that number is and then you back away from the part. It's a bad idea to stop a part with your cutting tool in contact. So I have to make sure that I use the relieved section of my calipers and I wiggle it around and I got a 0.599 reading for my diameter. So quick check, see what the print size is calling for, and I'm going to come back in and I'm going to touch. And while I touch, I'm going to look down at the dial and back up the part, and I'm making sure everything is matching up. And then when I feed in, I want to do a nice steady feed. And when I get to whatever number on the dial that I've determined, I immediately back away. If you let it rub, that's a good way to pick up chatter. And you heard it right there. It kind of squeaked a little bit. It's pretty common. Yep, I think I just might have killed anybody that had on headphones. I'll probably go back and lower that volume. Taking my measurement, and we're at 0.560. 562 was the perfect nominal size. 0.560 is close enough. We're happy. So here I am. Now, I think I can't remember what I did, but I bumped something. So if your first dial setting cut a perfect groove diameter, then when you go to your next groove, you can go back to that same dial number. But I had something get bumped. I think I might have moved my compound or something when I was messing around with the cameras. So again, I'm just taking a reading, just like on the first groove. And unfortunately, my second picture is in the way. Now I'm going to go in to my calculated depth. Now I'm going to feed to the right or maybe to the left. But anyway, I'm going to feed over to the shoulder, and then I'm going to feed over to the line. And that'll give me a 1/4 inch wide groove. It's a very easy way to go about doing this. and I probably should have just left my cutter in contact and then went ahead and moved to the right and the left. Um, but it's not a bad idea to check. So I'm at 0.562. That's an improvement from the first side. But like I said, 0.560 is good enough. You know, you'll find that a lot of measurements, especially this is a fractional dimension, uh, if I can get plus or minus 5 without really trying, then that's all you need. I'm feeding steady. Uh, don't, I have two hands on that carriage handle, so I have good control, is what I'm saying. Quick check. You can see I have almost a perfect quarter-inch wide groove at a good diameter. Now we're going to go ahead and we're going to cut that little 45-degree chamfer on that shoulder. Um, we're we're going to be turning the compound towards the chuck, and that means that in some situations you need to have slightly more tool overhang than you may prefer. But just keep in mind that we're taking a light cut, so if we're hanging out extra far, but we know we're going to be taking light cuts, it's going to work out okay. But you can see there that it would be a terrible situation if you weren't paying attention and you actually started the lathe with the chuck jaw making having interference with the compound. And that kind of stuff can happen if you're not paying attention. So, before you turn on any piece of equipment, you need to look at all the rotating parts to make sure there's nothing interfering with whatever's about to take place. I can't tell if I've given myself a layout line yet. I might do that up here in a second on film. But also remember, only the compound is moving on a 45-degree angle. You got to be very, very aware that you're not going to grab the carriage and try to make a cut with the carriage because the carriage is going in a straight line. Yeah, there I am. I'm just going to do a light scribe 16th back from the shoulder. We, if we're doing a 16th by 45 chamfer, um, we measure at a straight linear measurement. You don't tip a ruler at that 45-degree angle and measure the length of the actual chamfer. It's the linear length down the center line of the part. Also, I'm going to be going in with the cross slide. That's what I was just kind of motioning to the camera. Going in with the cross slide and then moving back and forth. And you're going to see, I believe I just I cut going both directions and I just inch my way to where I get to the line, and then as soon as the line disappears, I stop cutting, and it ends up blending into that radius uh, rather nicely. This is take your time, think about what you're doing, and have some confidence. Because if you think to yourself, "Hey, I'm going to screw this up," well, yeah, you probably will. So be confident. Say you're going to do a good job, and you have a better chance of actually doing that. With the RPMs right now, I'm definitely not going too fast. And you will find that if you sort of err on the slightly faster RPM selections when you're doing those hand feeding operations, you'll get a better finish. And you're not going to be in it long enough to burn up the tip of your cutter. Up next, we're gonna knurl the part. Um, I wanted to show this little trick. There's many ways of squaring up your tool post. I just grabbed a 1, 2, 3 block, and then I loosen my tool post. Now I'm sliding my tool post against the 1, 2, 3 block and the chuck. So now I know that side of my tool post is parallel to the face of the chuck or perpendicular to the center line of the part. This style of knurling tool is by far my favorite. Um, what we benefit from with this scissor type is the tool takes most of the pressure of the forming operation that is knurling. We do have the other more common style of knurlers in the shop, and I will teach you how to use them as well. But it's far easier to get a near perfect knurl with this tool. What I'm doing, I'm getting the wheels to where they will almost, I'm going to say cam over the top of the part. You don't want them to have a very narrow closed gap. You want them to almost be able to push over the top of the part. And that's how we keep the tool pressure in the tool and not into the lathe cross slides. RPM selection, 100 RPM or less. Uh, I've thrown a little bit of cutting oil down. That's just for lube. I'm getting a lot of it on the knurling wheels because those wheels don't have bearings. So I'm kind of having that be my lubricant, just for the knurler wheel that spins around that dowel pin. Now feed rate, 0.015 per revolution is fine. We can feed pretty quick when we knurl. In fact, we don't want to knurl at too slow a feed rate because then you're just overworking the metal, and with certain materials, it can work hard in, and then it starts to flake away. So I come in here, and I actually do notice that I can get too far over the part. So that means my wheels are open too much. So I'm just going to back off here, and I give it a little crank. I'm just tightening the bite. Oh, and actually it looks like I lifted the tool up a little bit. I kind of did a poor job of setting the centerline height. I'll show you in person in the shop, but basically you can see that nut and that bolt. That's the centerline pivot point. So if I were to just eyeball the tailstock center to that, that's how I could do it. So I'm doing my best to get a good look to see if I'm getting a good knurl. And then as soon as I'm happy, I engage that feed. It looks like it's feeding right now. You don't want to, again, you don't want to let it just sit there and spin in one spot with all the pressure that it takes, because you will have a ring, a mark in that section of the knurl. And if for some reason right now I wanted to stop and see what was going on, I would actually leave the feed engaged and I would just stop the spindle, take a peek at it, and if it looks really good, I would just start it back up so it could resume its knurl, the path that it's on. No complaints about the way this knurl turned out. There is a very, very slight witness mark from where I started the knurl, um, but when it's all said and done, I'm actually going to take this part, I'm going to sandblast it, and then heat it up and dunk it in some oil, and that's going to give it a blackened finish, and you won't be able to see the slight imperfection in the knurling. It'll look perfect. That'll actually wrap up this video. In the next video, we're going to face off that knob material that I'm holding onto, the extra length, and actually before that, we're definitely going to cut the taper. I'm not going to go over the math for the trig on video. We're going to do that in person at the chalkboard. And then we'll have another video when we drill the holes.